Hello everyone, welcome to my YouTube video. This is Dr. Song. Today I will talk about the hypothesis testing and then what Z-score means for this and also the power. I will just separate the different parts to explain about this in more details because in fact the many students they don't really understand about this hypothesis testing. So I think the conceptual level is very important to understand, and then that can be a solid knowledge to continue your quantitative research. So I think that is important to explain. So these are the three courses I adapted the contents from those courses to my course, so you will understand that is a reference. So about the test of normality. Okay, when we talk about how you will accept and then reject the null hypothesis and also alternative hypothesis, it's very important to understand really the crucial point. That is a p-value, that is alpha. So p-value is less than 0.05. That means that is 95%. The result is significant. So you will accept you will take your alternative hypothesis. That means that there is a significant difference, or that is also it's not like a normal. How can I say that? It's when you have the null hypothesis means that there is no effect, and then alternative is there is a effect. So you will accept that there is an effect. When it's less than 0.05, that means 95%. But you should be careful about this why it's alpha is less than zero point 0.5, and that is in fact the divided by the two part. So in the positive part and the negative part. So in fact, the point 0.5, no, 0.05, that means that 0.25, each part. So that is the together 95%. So in this case, you will consider that is a two part, like a bilateral. So the in the positive part or negative part, in any effect, you will consider that is an effect. You don't say the what effect in the positive and negative part, it's both parts. So in that case, it's bilateral, and then you have to divide the 5% with the 0.245%, and then 0.25% each part. However, when you say the unilateral, that means that it's only the 5% alpha that is for the positive part. In that case, you will put the 0.5 is only one part. So that is the unilateral and the bilateral, how you will put your hypothesis in the beginning of your research. So it's like, for instance, this one we can be the men are more how can I say that more distracted than women. If you say that men is more distracted than women, that will be the unilateral because you gave the direction, the positive part of the man. So in fact, that is the example of the unilateral. But if you say there is a difference about the distraction between men and women, and then that is bilateral. So the women or men, which one has the more distraction, that doesn't matter because you just give the hypothesis with there is a difference between the man and woman. In that case, you can just continue with the alternative hypothesis is there is a difference. And then, as I said, you give the which is more, and then that becomes unilateral. So if you put only one part, that will be the Z score 1.96. That is about the 0.2. But if you give the whole 5% to the only the one part, that becomes the 1.65. So your threshold of the Z score about this part, that is here is a 1.96, and then the other part is a 1.96. But if we put only this part, not this part in the negative part, that becomes here 1.65. So here is 1.65. Yeah. So you can see that this is the smaller amount than this one. In the maybe we can move the more like this. So this part is a more extended. That will be the threshold to decide that you will reject your null hypothesis or not. That becomes a bit bigger because you gave the part only the positive part without the negative part. So that is the very important to understand. So that is about this explanation here. So the 2.5% is divided by the two parts. And then this the bilateral that is most used in research. In fact, as a researcher, they just want to know there is a difference or not. They don't give the in general which is more or less. Just you want to see there is a difference. That is a bilateral, and then that is a conventionally used. The p is equal or less than 0.05. So that's why it's coming. This where from where it's coming is that, and that means that it's a 2.5% is divided by the two parts. Now, I just want to show you the where is used this also about the test of normality. So test of normality normally when you want to see if your data distribution is normally distributed, and then you will proceed with the normality test. So for instance, I will show you in the SPSS. So you have a lot of variables here. In the normality test, normally you will use only the continuous variables. So these are the nominal or ordinal variables. So we have to choose among the continuous variable. So let's just choose the one continuous variable with the satisfaction here. So you will go for the analyze and then descriptive statistics, and then you go to the explorer because that is the option of the normality test. And then you will put in the dependent list about the one of the continuous variable. We said that is what satisfaction here. Okay, and then statistics. So I will make a bit like this statistics, and then that is descriptive. Fine, continue. In the plot, instead of stem and leaf, we use more the histogram, and then normality plot with the test. That is very important. And then you will continue, yeah, and then you can do okay. So when you do this, there are a lot of information is coming. So the first descriptive about you will know where is the mean of this variable. So satisfaction is about the 66.16. That is the mean. And then you have the median and also you have the median. Yeah, you have the median. So that is if the big there is not a big difference between the mean and median. That means it's already good sign. Data is normally distributed. And then you can see the also skewness kurtosis and then with the standard error. There is the way also to find if there is a skewed or not. But let's just see about our concern of the test normality. Okay, so here you have the test of normality two kinds. A KS test, we call this K and the S test, and then Shapiro-Wilk. So the Shapiro-Wilk is more generous, and then the KS test is very rigorous. So it's very difficult to have the significant with the significance level about the normality is satisfied. So you can see that that is also less than 0.05. This is much less than 0.05. Okay, so please remember significance was less than 0.05. This one is also less than 0.05. So your histogram, when you click to make the normal curve line, you can put the normal curve line. Yeah, and then I will show you. Okay, so this you can see that you draw the normal curve line. That is in fact a bit negatively skewed. Yeah, but it's not very serious. But anyway, so that is showing that in the here is a normality test that is not really normally distributed. Yeah, so that is the histogram, and this is normality test. So based on that, let's talk about what is important. So so here you can see that P is less than 0.05, which is significant. But in the normality test, when you say there is a null hypothesis and then the alternative hypothesis, and the null hypothesis will be that is normally distributed. So is a normality is assumed. There is a data is normally distributed. And then another alternative hypothesis is non-normally distributed. Okay. So what you have to do when you have the p-value is less than 0.05, you have to reject this. You have to accept your alternative hypothesis. That means the data is non-normally distributed. So this is not what we want. So that is they are very important to judge about the normality test. When you have the result with the p equal or less than 0.05, that is the bad news about the test of normality, because you have to reject your in fact that you cannot accept the your normality assumed. I mean your null hypothesis. So in fact what we want is greater than 0.05. So we fail to reject our null hypothesis. So that means that they are normally distributed. This can be a bit confusing in the beginning, but when you think that step by step, you will understand. So let's continue about this explanation of the Z-score. Is a bilateral and the unilateral. I explained to that. Uh, And then this is again about more explains about the data score. In the two tails, that is a 2.5% each one, and then one tail is only 1%. It's only one part. So that is about the 5% totally about the one direction. Yeah, so that is what I explained. Also, you can take a look, like with your video, with the pose, and you can see that it's 0.05, it's 1.96, 0.5 is 1.65. So that is important to know. And then hypothesis test, there are four steps. So state the first hypothesis is what is the null hypothesis, and then alternative hypothesis. So this is 0, and then alternative. Formulate the analytic plan. So select the test. What kind of test you will do for no for the choosing which one you want to accept. Null hypothesis or alternative. Analyze the sample data and then interpret the report the result. So this is the four steps of hypothesis testing. So about this one, also we have to develop our concept of the type 1 and type 2 error. So very simply, this one can be also confusing, but very simply, type 1 error means that normally we cannot reject the null hypothesis, but when we reject, because your alpha is less than a 0.05, so we reject our null hypothesis and then we accept our alternative. But in fact, in the true life, your null hypothesis was correct. That is the case. In fact, that is like a totally your research was failed. Type 2 error, by the way, that is you accept the okay, you have to reject your null hypothesis. So in fact, this is a good news, because in fact the research result means that there the significant significance, but we didn't know about that. We made the error. So in fact we accept the null hypothesis, but it was not a good one. So in fact that's why we much prefer type 2 error, because in fact in the reality there is a significance. So this is about the type 2 error. So I will explain more about this one with the more slides next time. So it will be good to understand this concept. It's not about the to proceed with the test about the analysis, but it's good to enrich your concept about the quantitative research. That's why. Okay. So for today, this is all, and then I will see you next time. Thank you so much for listening.